Greetings, Algebra 2 students. I appreciate you finding time to do your notes. Today's information is titled The Discriminant. Our objective for this day will be the student will learn to understand what the discriminant of the quadratic formula means to the type and number of solutions. Not exactly sure what the date for this will be. I think it might be Thursday following the Thanksgiving break. We'll have to see how the week unfolds. Copy down the objective. You might just leave the date blank for now, and we'll fill it in as it gets a little closer. Press pause anytime you need more time, and then hit play when you're ready to move on. Okay, now we've been looking at the quadratic formula. You can probably skip that top part there, okay? But for any quadratic, ax squared plus bx plus c equals 0, or we've basically emptied out one side of the equation, allowed it to equal 0 so that we could solve for x. The quadratic formula there on the right side gave us the possible solutions for the x values. Now what you should have been seeing is that based upon the quadratic equation that we are working with, we had three different options that might have resulted from using the quadratic formula. Okay, we could have seen that we had a single real number that came out of the quadratic formula. It was possible that we might have two different real numbers as answers for our coming out of the formula. And it's also possible that we could have had two different imaginary solutions coming out of the formula. Okay. Now the type and the number of solutions that we just discussed above is determined by what is referred to as the discriminant of the quadratic formula. And in short, the discriminant is the information that appears underneath the radical, the b squared minus 4ac. When this value has its variables plugged in for and it's simplified, whether we have one solution or two solutions, or whether those solutions are real or imaginary, all comes from this value that's called the discriminant. Now, the three different things that could occur is that your discriminant, b squared minus 4ac, could be exactly equal to 0. Now, when that happens, if you think about your formula, what you have is negative b plus or minus the square root of nothing. Now, of course, the square root of nothing is nothing. So whether you have negative b plus 0 or negative b minus 0, it's not going to change that value one way or the other. So essentially, you get the same answer twice. So we would only end up with one solution, and it would be real. Because the only way you can end up with an imaginary answer would be if you have a negative underneath the radical. And we don't even have a radical anymore, since the square root of 0 eliminates itself. Also, the discriminant could be a value larger than 0. Now, if it's a value larger than 0, then what that means is underneath our radical in the quadratic formula, we have a positive number. Because the square root of a positive number is always going to be real. So we will have real solutions. And since the radical cannot eliminate like it did in the first one, okay, it doesn't go all the way to 0, then we have negative b plus whatever that square root is, and negative b minus whatever that square root is. So we have two different answers. And then the final possibility is that the discriminant could be smaller than 0. If the discriminant is smaller than 0, then of course we have a negative value underneath our radical, and we know that a negative underneath a radical is going to give us an imaginary solution. And since the radical does not just simply go away, it's not equal to 0, then we are going to end up with negative b plus this square root of a negative number and negative b minus this square root of a negative number. Okay. So there are the three possibilities. Based upon what the discriminant does, we should be able to anticipate how many solutions we should get and what type of solutions we should get. Okay, so obviously this gives us a way to anticipate our answers before we actually see them. That's always a good thing in mathematics, that the higher you go, the more you will learn that instead of solving a problem and then double checking it, what you will learn to do is that your brain will learn to anticipate what the answer should be, and then working the math is actually the double checking. So it's like the math is verifying what your brain already knew was going to happen. Okay. So let's have a look. Examine the discriminant and let's see what type of solutions we will get. Okay, so we're not actually going to go through and solve it. We're just anticipating the type of solutions. Okay, so we want to take our quadratic. We want to make sure that it is in standard form so we can get the A and the B and the C values correct. Our equation is already in standard form. Our A value is 1, B is 4, and C is -2. Since we're just trying to find what type of solutions we're looking for, then we're only interested in the discriminant, so only the b squared minus 4ac. So that's our formula. So write down your discriminant formula and your a, b, and c values. Then we would plug in our numbers and see what happens. Okay. So when we plug in our values, we end up with 4 squared minus 4 times 1 times -2. So let's simplify it and see what happens. Obviously, 4 squared is 16, and then from that we will subtract 4 times 1 times -2, that is -8. So we have a double negative in there, so it's 16 plus +8. 16 plus 8 is 24. So what does it mean when we have a positive discriminant? Well, we have a positive number underneath our radical that will give us real solutions. And since the radical does not zero out, there will be 2 solutions, 2 real solutions. Okay, let's look again. What kind of roots will we get from the following equation? -2x equals -3x squared minus 8. Okay, well, before we begin, we're going to get our quadratic in standard form. Now, as you can see, we have values on both sides of the equal sign. We can actually send all of the information either direction. It does not matter which way we send them. Okay. Personally, I am going to send everything to the left, if I remember correctly, because actually standard form is most appropriate when the A term is a positive number. Right now, as it stands, our A term would be a -3. Okay, so sending it to the left would make it positive, and that would be better. Okay, so by adding 3x squareds to both sides and adding 8 to both sides, everything is brought over to the left side. The A term is positive, and as I said, that's what's considered to be most appropriate, to have a positive A term. However, if everything had gone to the right, you would still end up with the same answer. All right, so our A in this case is going to be a 3, B would be a -2, C would be a +8, and of course we need our discriminant formula, b squared minus 4ac. All right, let's plug into the discriminant. We get -2 squared minus 4 times A, which is 3, and C, which is 8. -2 squared is going to be a 4. And then we have 4 times 3, which is 12, times 8 is 96. So we're going to get 4 minus 96. So 4 minus 96 is -92. So what does that mean to this quadratic? We will have a negative underneath a radical. That will cause our answers to be imaginary. And since the radical will not zero out and go away, then we will have 2 solutions. So 2 imaginary solutions. Okay, I'm going to give you one more, and I'm going to ask you to give this one a try on your paper. What kind of roots will you get from the following equation? You have negative x equals negative 3x squared plus 4. Move everything to one side of the equation, plug it into the discriminant, and let's see what the discriminant tells us about the type and number of solutions. Well, there you go. You got some shorter notes today. So for those of you that complain about how long the other ones are, here's your opportunity to knock it off and quit complaining. Anyway, appreciate you taking time to figure out your notes. We'll see you in class.